Hi everyone and welcome to CV channel, the channel about computer vision, programming skills for developer. Today in this video, I will continue show you how to implement a pre-trained deep neural network for object detection by using OpenCV. And the next step, you need to create a function for run the deep neural network for a specific image. In here you will need create a function with specific image. You need to convert the image to 4-dimension blob. You can use the blob image, blob from image. The scale. This is the scale factor because your input image is in the range from 0 to 255, and you need to scale it to the value from 0 to 1, and you need to scale by this factor. And the next size, the size output. And the mean, I will set it on 0. Square. In OpenCV, each pixel RGB will be saved from BGR, and use swap to swap it to RGB. Crop, we don't need crop. Oh. The next step, we will set blob is the input of the network. And run the network. You need a variable for saving the output. And the input of the forward command is a variable for saving the output values, and the name of the output. The next will be design the class for bounding box. The output data will be include the first four parameters will be for the location of the bounding box, the width, the height. That is the first four parameter, and the next will be the confidence scores. It will include n plus 1 values. One for the confidence of the bounding box. It will include an object, and n will be the number of the class. As in this example, the class will be the number of the class will be 80. 80 plus 1 is 81, and plus 4 is 85. And in here we will implement the part for reading this information, and we will if the confidence of object is greater than or equal the confidence threshold, it will include an object. And in here we need the parameter for saving the confidence, the class ID, and the rectangle of bounding box. That is the confidence of the bounding box. And the next is class ID for bounding box. Next is the rectangle of bounding box. We need for saving the data. And next step, you will load the value from each bounding box. After loading the object detection, you need to check whether will exist an object in the bounding box. You need to check it object is greater or equal confidence. Next, you will decide the ID for the class by get the max value in here. You can use the min max log function. And next, you will decide the information for the bounding box. Because the output of each value will be scaled from 0 to 1, and you need to convert it to the value, the position of the image. Saving the values. This function for next round. You only need simply by the shift the pointer of the variable. After deciding the confidence as well as the class ID of the bounding box, you need to remove the unnecessary bounding box. You need to use the non-maximum suppression algorithm to remove the unnecessary bounding box, because if you don't use this algorithm, there are many bounding boxes for the same object, and you need to remove it by apply the non-maximum suppression, and you need to remove the bounding box. Indicate the same object using the NMS. But here I will set the NMS threshold is 0.4. And next I will save the bounding box. For saving the bounding box, I need to add more variable in here. I will need an object for saving the object name. And to do this, I need to declare a type. This new type will name be Yolo object type. The first is for saving the bounding box rectangle. The second for the class ID name. And the next is for the confidence. You need to declare a new variable. And you go to the source file. Save it. And after finish the run on frame function, and you need to add the function to get the object variable.